So now that we've looked at stress, let's go ahead and take a look at strain. So let's say this 2-inch cable, while Anderson was hanging on it, let's say it stretched a little bit. Let's say it elongated. So the elongation or the stretch, let's say that equal the 1/4 inch, so 0.25 inches. And so what does that look like? Well, let's take this rope and let's say he's pulling on it. He's hanging from it, so he's pulling on it a little bit. And he pulls it down just a tad bit. Let's say that's a 1/4 inch. And so that's what happened. This gets a little bit longer. Because he's pulling on it, the whole thing stretches out just a tad bit. And that's a gross oversimplification of how it would stretch, but you kind of get the idea. So the question is, what would the strain be? And of course, the formula for strain, so let's go ahead and draw that. That's epsilon, or a backwards 3. Well, that's delta, or change in length, so delta over the original length. Well, we already know delta. We just said, let's say it grew a 1/4 inch, and we know the original length as well. We know length original, L0 equals, or LO, not L0, for original, is 10 feet. But you might recall that this has to be in inches, so that's, well, 12 inches in a foot is 120 inches. And so this really isn't that complicated. We get epsilon is change in length over original length. Well, the change in length we just said is 0.25, or a 1/4 inch. And we divide that by the original length, which is 120 inches, or 10 feet. And we get a strain of about 0.0021 equals epsilon, or strain. And remember, strain has no units. And if you look here, we actually have everything we need to find our elasticity, which can be denoted as E. And let's say we find E, well, with a precision of 1,000. Well, the formula for E is just very simply stress over strain. So we do sigma over epsilon. Well, we know both these values. We know stress we just got was 47.8 psi in this example. And we just found epsilon, which is 0.0021. And if we plug that in, we get a little bit less than 23,000 psi. But it said round to the nearest thousand, so we're going to round up to 23,000 for the modulus of elasticity, psi. Which we can actually use to find out what the new delta will be over here. We'll call it delta thick. We can see how much this one will elongate. Assuming it is the same material, then it'll have the same elasticity. And we'll do that in the next video.